So we've got the thermite reaction, the big reaction, the thermite. We're reacting aluminum versus iron. Who's going to win? Who do you think is going to win? Aluminum is going to win. So that's in here. But before that, we're going to try the initiating reaction with this black powder. This is the way we used to start the reaction with potassium permanganate. But this reaction isn't reliable because these chemicals have been kind of shoddy. Then after that, we're going to start off the thermite reaction. We're by a busy street, so it's a little noisy. We're going to start off the thermite reaction in here using the flash demo. The flash demo is going to start it off. Flash demo is magnesium with silver nitrate. So that's going to be something I'm going to add in here on top of this. So right now inside this one we have potassium permanganate. After the initiating reaction, we're going to react these two chemicals. We're going to react basically what amounts to rust. It's the same thing as these little pieces of rust I found off of a little bench. It's hematite. Hematite is rust. And then this one is aluminum powder, which is the same thing that is in aluminum foil, which I have right back here. It's the same exact thing as aluminum foil, just in powdered form. And then I've mixed them together, and notice that the color doesn't, you don't even see the aluminum anymore. All you really see is the hematite because it overpowers the aluminum, it coats it. We're gonna do a few neat tricks in here. One of them is we're gonna try to melt an ionic compound. Remember, ionic compounds or salts are very hard to melt. Here's one, this little cube here. It's very hard to melt because of the ionic compound structure, like this. You can shake them a lot, they're really not going anywhere. So you can shake them and shake them. It takes about 800 degrees Celsius to melt these, which is like 1,500 Fahrenheit to melt them. So it's hard to use a thermometer. We don't usually, oh, and I've got a little piece of this right here. This is the same as a small one. I think it'll be easier to melt a small one. Another thing we're going to do is have an actual thermometer. We don't usually do this. This thermometer is probably going to be destroyed by this reaction, but I have it set on max, so it'll record the maximum temperature. It'll record the maximum temperature that it reaches. Okay. Also, I'm going to use a little bit of cellulose or paper because cellulose famously, remember this? Cellulose famously will begin to combust if you reach that temperature. You gotta put some sand on it to hold it down, okay? And I'll put the salt on top. If you reach that temperature of Fahrenheit 451, okay? Of course, Fahrenheit is garbage. Fahrenheit we don't really like to use in science. It's a terrible, terrible scale. So what do we use? Celsius. In Celsius, that's 233. 233 Celsius. But there's an even better scale, better than Celsius. What is it? Do you know? Kelvin. So what we're really going to reach, well, 506 Kelvin is when that paper will spontaneously burst into flames. So if you see that paper burst into flames with no match, we've reached that. This will record a temperature. This will probably go bye-bye. We won't worry about that. And the ionic compound will melt. There's one more thing I want to try. One more thing I want to try. Because, remember, one ring to rule them all, one ring to bind them, one ring to bring them all, and in the dark, I think I misquoted that. Anyway, Lord of the Rings. So in honor of Lord of the Rings, I'm going to put a little piece of platinum in here. This will probably be okay. We'll see if it melts the platinum. I'm going to put that in there. I'm going to put it next to the ionic compound. So we'll have a little bit of platinum, a ring, like if this is Mount Doom, because this is going to come out as hot as lava, maybe it'll melt the ring or just start to melt the ring. We'll see what happens to this piece of platinum and this ionic compound. A metal and an ionic compound. They're going to be smothered with a whole bunch of the products of the thermite. The products of the thermite are going to be alumina and iron, molten iron. They will come out at a temperature that is hotter than any lava, anywhere, any lava. So this is the main reaction, but before that, we're going to try a little side reaction, the initiating reaction. That's the first one, the initiating reaction. So my lovely assistant Lucy, come closer, is going to put glycerin, which is this one, into the potassium permanganate. Go ahead, Lucy. Put it in, put a big dollop. And this should start, okay, that's enough, stop. Yeah, that's good. Now walk away back behind the safety line, thank you. This should start off a pretty flashy reaction. The problem is the potassium permanganate we've had lately has been of lower quality, so we can't usually rely on this to start our thermite anymore. But since it's such a great reaction for balancing, it's one of the hardest reactions to balance, because actually what it does is it skips a bunch of steps. There's the potassium permanganate, there's the glycerin, yes, that's true, but then lots of things happen before you get to these products, which makes it a really hard equation to balance as well as to predict a reaction type. Quiet. There it goes. There's the initiating reaction. So now notice it's smoldering, but it really didn't do all that much. That's kind of what I expected. So that wasn't enough to start the thermite. But the great thing about seeing that reaction is that you can now try to balance it. You can try to balance this crazy one now that you've seen it. That was glycerin reacting with potassium permanganate. Now I am making a little crater into the thermite materials, and I'm adding the materials for the flash demo. This is quite a bit. This is the magnesium and the silver nitrate, as you see over there. Now when they're dry, they have no problem with each other. It's only when they get a little bit wet that they react. So I'm putting the flash demo right on top. All it's going to take is a drop to get this one going, and then when this one goes, Ian, wait, come over here, Ian, so you're back there, and show the squirt bottle. Stand back there. Don't squirt. Stand over there so you're in the camera. Ian's going to squirt with the squirt bottle, not from here, not from here. Not right now. Okay, you're going to squirt, now go back. And his little drop of water that's going to land in here is going to start off the flash demo. It's going to be flashy, really quick. Then the thermite's going to get going. Like lava, hotter than any lava on Earth or Mars or Venus or anywhere. It's going to pour out onto the one ring to rule them all, and onto the ionic compound, and onto the cellulose, Fahrenheit 451. So what we're going to see is, these are three ways of measuring how hot it gets. Does it get hot enough to melt ionic compound? Sodium chloride, that's 801 degree. Thermometer might survive, we'll see. It'll tell us how hot it was over here. The paper, if it bursts into flames, that's Fahrenheit 451. I'm going to try to grab it while it's molten and show it to you and to my kids. And it's a little hot, so I've got my thermal gloves. All right. So Ian, you can move up to squirt it. You can move up to here and then step back. He's squirting right now. Squirt that, not the camera. Squirt. Watch it. Stand back. Here it goes. That's going to get it going. That's going to get it going. That's going to get the thermite going. Look at this. Look at this. That's a good thermite. Whole lot of thermite. Whole lot. Molten material flowing out. Okay, let me see. Okay, I think the thermometer is actually still survived. Did the paper burst into flames, guys? Did the paper burst into flames?
Yeah. That was so cool.
Look at how big this chunk is. Oh, wow, molten. Molten, right? Oh, it's burning up my papers. Uh-oh. So we might, okay, I was gonna see if it was magnetic. Oh, it's still molten. Here's a piece, here's a magnet. Nope. Okay, look at that chunk. Let's try to tap some out. Let's try to tap some out. Look at that, look at that. Look at that. Molten, is that cool? Hotter than any lava. Hotter than any lava. We didn't start any fires, did we, guys? I'm gonna throw this down. Boom. Oh, it's gonna mold it. What? On the what? On there? That's fine. Is that cool? Is that molten? You see that? Molten, look. You see that? Don't come too close. You see that? That is a big chunk of molten Now that's not all iron. It's actually, it's when it cools off, it'll look like this. When it cools off, it'll look like this. It's alumina and iron. That is the most exothermic reaction we have in chemistry. See, oh, now it's magnetic. Look. Oh no, that might be the tongs. It's too hot to handle. I gotta get the magnet off. Okay. Let me see. So a little bit of it did not react. I put so much in that it went through the middle. It went through the middle of the pot, and some of it didn't react. So I'll salvage that for later. But that was a very good demo. That was the Thermite demo. Was it Fahrenheit 451? Was it Fahrenheit 451? Oh, where's the ring? Oh, one ring. One ring to rule them all. One ring to find them. One ring to bring them all. Squirt this with water, Ian. See if it sizzles. Squirt these with water. See if they sizzle. Squirt that and this. Squirt at them. From there. Squirt. Can I see it? Can I see it?
No, Dad.
Can I see it for a second? I want to see if it sizzles. It's so hot. That's how hot it is, guys. Because actually.
Oh my God, Dad! When
No, stand back.
It just broke.
So this is just in case there was a fire.
That's just so.
See that? So by the way, it was probably at about 2,000 degrees Celsius, which is well over 3,000 degrees. This is melting my shoe. Let me see what happens if I pour some water on it. Now this could make a bunch of steam. Watch out. Watch out. I'll put this in. Is it in the camera? I think so. Let's see what happens here. That's why they recommend you don't do the Thermite over water. Like let's say there was water in here. It would all turn into steam. It could be a big problem, steam rushing out. And let's pour some in here. This is going to be the tricky part. I'll squirt it into there. I don't want it to steam my face. So I'm going to squirt it into the flower pot. I don't usually do this. Okay. Okay. Well, that's it, guys. That's it. Can you believe that? So my lovely assistant, Lucy, come closer, is going to put glycerin, which is this one, into the potassium permanganate. Go ahead, Lucy. Put it into the big dollop. And this should start, okay, let's have it stop. Yeah, that's good. Now walk away back behind the safety line. Thank you. This should start off a pretty flashy reaction. The problem is the potassium permanganate we've had lately has been of lower quality, so we can't usually rely on this to start our Thermite anymore. But since it's such a great reaction for balancing, it's one of the hardest reactions to balance, because actually what it does is it skips a bunch of steps. There's the potassium permanganate, there's the glycerin, yes, that's true, but then lots of things happen before you get to these products, which makes it a really hard equation to balance as well as to predict the reaction type. So let's see if we see any smoldering. Quiet. There it goes. There's the initiating reaction. So now notice it's smoldering, but it really didn't do all that much. That's kind of what I expected. So that wasn't enough to start the Thermite. But the great thing about seeing that reaction is that you can now try to balance it. You can try to balance this crazy one, now that you've seen it. That was glycerin reacting with potassium permanganate. Okay, so now I am making a little crater into the Thermite materials, and I'm adding the materials for the flash demo. This is quite a bit. This is the magnesium and the silver nitrate, as you see over there. Now when they're dry, they have no problem with each other. It's only when they get a little bit wet that they react. So I'm putting the flash demo right on top. All it's going to take is a drop. Step back. He's squirting right now. Squirt that, not the camera. Squirt. Watch it. Watch it. Stand back. Here it goes. That's going to get it going. That's going to get it going. That's gonna get the thermite going. Look at this. Look at this. That's a good thermite. Whole lot of thermite. Whole lot. Molten material flowing out. Okay, let me see. Okay, I think the thermometer is actually still survived. Did the paper burst into flames, guys? Did the paper burst into flames?
Yeah.
Okay.
That was so cool.
Look at how big this chunk is. Oh, wow, molten. Molten, right? Oh, it's burning up my papers. Uh-oh. So we might, okay, I was gonna see if it was magnetic. Oh, it's so molten. Here's a magnet. No? Okay, look at that chunk. Let's try to tap some out. Let's try to tap some out. Look at that. Look at that. Look at that. Molten. Is that cool?
That is so
Hotter than any lava. Hotter than any lava. We didn't start any fires, did we, guys? I'm gonna throw this down. Boom. Oh, it's gonna mold it. What? On the what? On there? That's fine. Is that cool? Is that molten? That's molten. Look. You see that? Don't come too close.